Hello, ladies and gentlemen. I hope everyone is doing well today. Today we're taking a look at the formal charge Chemquest. So we'll use these when we are drawing Lewis structure. So if you remember, or maybe you've noticed when you're drawing Lewis structures, that sometimes it seems like there can be multiple correct structures. If you've been thinking that, then you are correct. That is the case. So we use formal charges to determine which structure is better. So right down here, we have the structure silicon dioxide, which is sand. So the structures for silicon dioxide, there are two structures, structure A and structure B. We are going to use these two structures to answer the first few questions. So in question one is asking us, does each structure have the total number of correct valence electrons used in the structure? So we know that silicon has 16 valence electrons. Well, how did we figure that out? So remember, we have to add it up. So we know the structure, looking at my pencil, is silicon, so one silicon and two oxygens. We don't have that on our periodic table, but we do have silicon and oxygen, so we can add it together to figure out how many total we have. So remember, the valence electrons correlates to the column it's in. When you're in column 14, it has 4 valence electrons. So that's why you see this 4 right here. Remember, this is the electrons in silicon. Then we multiply by 1 because there is 1 silicon in our formula. We do the same thing for oxygen. Oxygen is in column 16. Everything in column 16 has 6 valence electrons, so that's where the 6 came from. We then multiply by 2 because there's 2 silicons in our structures. 1, 2, 1, 2. Then that gives us a total of 16 valence electrons, or 16 electrons in our formula. Next, question 2. Oh, we need to double check and make sure that every formula every structure has the correct number. Sorry, guys. So remember, the lines equal 2 electrons, the dots equal 1 electron, so we add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Structure A is good. Now we do the same thing with structure B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So yeah, we see that both structures have the correct number of electrons in them. Next, in question 2, we need to double check this, make sure that it follows our rules. So remember, the main rule that we need to follow is every atom wants to have 8 electrons around it. This gives it a full outer shell. Remember, this gives it a full outer shell. That makes it stable, which makes it stable. So we need to double check and make sure that every structure has 8 valence electrons around it, or every atom in the structure. So we start with the oxygen on the left. We count it up. 1, 2, 3, 4, 5, 6, 7, 8. Good. We check silicon. 1, 2, 3, 4, 5, 6, 7, 8. So we're good. Now we check oxygen. 1, 2, 3, 4, 5, 6, 7, 8. We're good. So structure A has 8 around every atom. We do the same thing for structure B. We count them up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is good. We do silicon. 1, 2, 3, 4, 5, 6, 7, 8. Silicon has 8 is good. Now we do the same thing for the last oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Awesome. So now we double checked. Yes, every atom has 8 electrons around it. So in question 3 is telling us that according to experiments, we know that the structure of silicon dioxide has 2 identical bonds in it. So which structure is correct, A or B? That would mean A is correct. Hopefully you said A, because A has 2 double bonds in it. Those bonds are identical, whereas these bonds are different. This one on the right, so the first oxygen bond has 1 line, and the second oxygen silicon bond has 3. So as you can see, those bonds are not identical. These bonds are identical because they have the same number of lines. So we see structure A, it has the same bond, 2 lines. So then moving on to formal charges. So remember, when there are 2 possible structures for a compound, we can always use lab data, like we did in question 3, to determine what the better structure is. However, if you don't have lab data, we need to use formal charges. So to use formal charges, we need to learn about formal electrons. Formal electrons are electrons that are not being shared. So they are the electrons that are around an atom. So electrons that are around an atom. So what you need to remember, what you need to know about this bond right here is in reality there is one electron next to oxygen, one electron next to silicon. Well, it might be tough to see, but you can kind of see that I added some dots on the ends of the lines. We do the same thing to the other bonds. We add dots to the other side. So our formal electrons are going to be all of the electrons that are around this oxygen. They are going to be all of the electrons that are around silicon, and they're going to be the other electrons that are around oxygen. So that is how we determine formal electrons. They are the electrons that are surrounding the atom. Remember, our bonds are broken up into two electrons, one on each side of the line. So the way we can calculate formal charge, the way we can calculate the charge of the atom, the formal charge, is by using the formula. Formal charge equals the number of valence electrons minus the number of formal electrons. So we just figured out how to determine formal electrons. They are all of the electrons that are surrounding an atom. Remember, valence electrons are easy to determine. We already wrote all of the valence electrons. We put them in boxes on our periodic table so we can quickly determine the valence electrons. So if we were to calculate the formal charge of this silicon dioxide atom right here. So when we calculate this charge, we would start with silicon, or we can start with any one of the atoms. Down here I started with silicon, so we use the formula. Number of valence electrons minus the number of formal electrons. So we come look at our formula. Silicon, our periodic table, has 4 valence electrons, so that's where you see this 4 come from right there. Silicon also has 4 formal electrons. Look, it has 1, 2, 3, 4. 4 minus 4 is 0. Next, we do the same thing for oxygen. This is the first oxygen. Remember, oxygen number 1 is labeled on the left side. So we start, oxygen is in column 16. It has 6 valence electrons. So that's where you see the 6 come from. We then subtract 7. It has 7 formal electrons. 1, 2, 3, 4, 5, 6, 7. So that's where that negative 1 comes from. 6 minus 7 is negative 1. Oxygen number 2, we do the same thing. Oxygen still has 6 valence electrons. It doesn't change because we just went to another oxygen atom. Now we can count up the formal electrons. It has 1, 2, 3, 4, 5. So 6 minus 5 is 1. That is how you calculate the formal charges. So next, question 4. In question 4, we can calculate these charges to practice. So remember, we start by drawing the dots on either side of our line. If it helps you to draw circles like I did up here, please feel free to draw some circles around your atoms. So the first one, we have oxygen. So we can draw a circle around that oxygen. Draw a circle around the silicon. And then we can draw circles around the opposite oxygen. So it is worth mentioning that because this is symmetrical, because you have the same bonds, the same number of electrons on both sides, you only need to do one of the oxygen atoms, and then the other one is identical because it's a mirror image. If you were to put a mirror in silicon, it would look identical. So we can do it for oxygen, and we can do it for silicon. So if we go for oxygen first, remember oxygen, 6 valence electrons, then we can subtract from the formal electrons. So we can count them up. 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. I'm going to put a little dash through it so you don't confuse my zeros with oxygens. Next, we do the same thing for silicon. Silicon has 4 valence electrons according to our periodic table. We can subtract from the formal. We count around. 1, 2, 3, 4. 4 minus 4 is 0. So yes, we see here that the formal charge for all the oxygens for silicon is 0. So question 5. Question 5, we need to take into account questions 3 and question 4. In question 3, it tells us that structure A is better because it has identical bonds. Because structure A has identical bonds, we know that it's the more frequent structure. So we also know that we calculated the formal charges. the formal charge for everything in structure structure A in question 4 was 0. Up here in our diagram 2, we calculated the first oxygen as -1, we calculated silicon as 0, and we did calculate oxygen as +1. So we know that this in question 4 is the better structure. We also know that they have all zeros. So what we can tell from this as it's better to have more formal charges of 0. That makes it more stable. So it is better to have more formal charges equal 0. The more formal charges you have of 0, the better it is, the more stable it is. Because if you think about it right now, down here in question 4, these structures, these are evenly spaced. They're not attracted to each other, so they're not moving. Down here, over here in this structure, we have a -1 and a +1 on opposite sides. So in reality, they're kind of trying to push that silicon, smush it together, so those oxygens are trying to be brought in together, making the bonds squished, not as stable as the bond down here when the charges are evenly spread out. So over here on question 6. So question 6, it asks us to draw I'm on the wrong question, I was on 8. Question 6 draws us as the Lewis structure of carbonate. So I already drew the Lewis structure for us. This time we are going to practice calculating the formal charges. So we can write the formal charge formula on the top of this to help us. Remember, formal charge equals number valence electrons minus the number of formal electrons. So when you're calculating the formal charge, the first thing that you should do, and we're going to make some steps on the side, is to draw Lewis structure. So we've already done that, so we've done step 1. Step 2 is then to draw the formal electrons. Remember, when we draw the formal electrons, we draw 1 electron on each side of our line. Step 3 is to then calculate formal charge. So we use the formula number of valence electrons minus number of formal electrons. So for this first oxygen on the left, so we know oxygen has 6 valence electrons. We can count up the formal. Remember, if you want to draw circles to help you, you can. All of the electrons surrounding that oxygen. So we count them up. 1, 2, 3, 4, 5, 6, 7. So the formal charge of this oxygen, 6 minus 7, -1. You do the same thing for the bottom oxygen. Oxygen still has 6 valence electrons. We count up the formal. 1, 2, 3, 4, 5, 6, 7. 6 minus 7, -1. We do the same thing for the next oxygen. Circle the formal electrons. Then we count them up. 1, 2, 3, 4, 5, 6. 6 minus 6 equals 0. And then lastly, we do it for carbon. So we go back to our periodic table. Carbon has 4 valence electrons. Oh, there it is, 4 valence electrons. So then we can circle the formal. So we can count them up. 1, 2, 3, 4. 4 minus 4 is 0. So what we can do here is we can add up all the formal charges, those that we just finished calculating the formal charges. So now we move on to question 7. Question 7 is asking us to add up all of the formal charges. So we can start with the oxygen. -1 plus -1 plus 0 plus 0. This equals -2. So what do you notice about the charge in the formula and the sum of the formal charges? What do you notice? What you notice will help you answer question 12. So what you guys now need to do, so I drew the Lewis structures out for both 8 and 10. This way you have correct Lewis structures. Now you just need to practice calculating the formal charges. Compare what you notice about the sum of the formal charges to the charge in each to the charge in each of the problems. What do you notice about the sum? What do you notice about the overall charge? That will help you answer question 12. Then when you are done, you can move on to question 13. Try your best to determine which is the best structure. Remember what we learned over here in question 5. Remember, the best structure will have more formal charges that equal 0. So we know best structure, most formal charges that equal 0. So you will have to go through and calculate the formal charge for every bond. Then you will determine which one has more zeros. The one that has more formal charges that equal 0 is the better structure. Like always, if you have any questions, please circle them and bring them to class. And here we go. I'll end with a joke. So what did the fish say when it swam into the wall? Damn. Well, I hope everyone has a great day, and I will see you next class. Bye.